Okay, we're going to solve some more problems using properties of radicals, and these are also from page 268, so I got 3 more problems to show you, and then you should be fine with your homework. So, let's go with number 46. Cube root of 8c over 9d to the 5th. First thing to do is rewrite it as cube root 8c over cube root 9d to the 5th. Now, at first glance, hopefully you know that some of this d to the 5th can come out of the radical. That d to the 5th could be thought of as we have cube root 8c over cube root 9d to the 3rd times d squared. I separated that so that I have a perfect cube. Do you know which one is the perfect cube? D to the 3rd. So I'm going to rewrite that as cube root 8c over d cube root 9d squared. Now, it looks like it's pretty much simplified, and it is, with one exception. Can't have a radical in the bottom. So, if that 9 was a 27, and if that d squared was a d to the 3rd, then I could simplify this. So, here goes. Multiply by our magic number 1, being any fraction we want, something that's going to make this work out real nice. Watch what happens. The magic fraction I'm going to use is going to be a cube root fraction. I want that 9 to be a 27, so I'm going to multiply it by a 3. I want that to be a d to the 3rd, so I'm going to multiply by d. What I do on the bottom, I also do on the top. Now, just a matter of simplifying. The top becomes cube root 3 times 8, 24 cd. You know what? I'm not going to mark it 24 cd because I just realized that 8 is a perfect cube. So, let's do 2 to the 3rd times c times d. And the bottom, I'm going to write d, then I'm going to write cube root. 9 times 3 is 27, which is 3 to the 3rd. D squared times d, d to the 3rd. Now at this point, if you look for all the perfect cubes that can come out, 2 to the 3rd, 3 to the 3rd, d to the 3rd. What happens? Let's see. 2 to the 3rd, so a 2 can pop out. So 2 cube root c d. On the bottom, I have this d already out there. A 3 comes out. A d comes out for the d to the 3rd. No radical left. Neaten this up a little bit. Final answer, 2 cube root c d over 3d squared. Now I have a little question for you, though. Whoops. Can you see that a little bit better? There. Can you reduce that? Can I reduce that d with that d? You better say no. You cannot reduce anything inside a radical with something outside of a radical. So be careful. All right, 2 more quick problems. This, it looks like 16 has a perfect square 4 times 4. But that plus sign is a real problem. The only way you can take something out of this radical is to write it as a multiplication problem inside. I can do that by factoring 16 times a plus b. And then, do I have a perfect square in there? I sure do. 4 times 4 is 16, so 4 root a plus b. There she is. Look at 49. Factor 2a squared plus 2a plus 1. That factors. That watch this. 2a plus 1, a plus 1. Hey, 2a plus 1 squared. Do I have any perfect squares in there? I hope you notice I do. The square root of a plus 1 squared is a plus 1. So that can pop out. What's left inside? Root 2. A plus 1, I have to put in absolute values. Why? Even roots, if a variable comes out, you need an absolute value symbol. So, that's that. There's your answer. There's your answer there. Hopefully, this helped with those problems.